So thus far we've been talking about finding derivative of functions that are expressed excuse me, in the explicit form. And I'm going to give you an example. For example, if I have y equals 3x squared minus 5, this is called the explicit form of this function, okay? Explicit. And why do we use the term explicit? Because the function is clearly defined. You know that y is in terms of x. Y equals 3x squared minus 5. Now, to find the derivative of this is pretty simple. If you want to find the derivative of this function in terms of x, we call that dy over dx, right? Or you can call that y prime. That's another way to write the derivative. It's just going to be straightforward, okay? We use the power rule, and that's going to give you 3 times 2 times x, 2 minus 1, and the derivative of 5 or any constant is 0. So this ends up being 6x, okay? So that's the derivative. So now, the problem comes when sometimes the function is not expressed explicitly, in the sense that it is not, y is not clearly defined, it is implied. Let me give you an example. If I have x squared minus y squared plus 3y cubed equals to 5. And the question is find the derivative. Now, if you can see here, what's going on here? Y is not clearly defined in terms of x. So this is called the implicit form of the expression or the function, the implicit. Something is being implied here, implicit form. Now, I'll give you an easier case so that you can understand that. So let's say I have x times y equals 1. I can clearly solve for y here, right? So y will be equal to 1 over x. Now this is called the explicit form. And this is called the implicit. Implicit because something is being implied here. Basically, you can solve y in terms of x. This is the common case, right? So you can solve y in terms of x. This is called the implicit format. Now this is called the explicit because y is clearly defined in terms of x. Now, how do you find the derivative of a function like this? This is more complicated. Now, first let's take a couple of cases. Let's assume that we have this here. I want to find d of dx of 3x squared. Okay, I want to find d of dx of 3x squared is called the derivative. Okay, you want to differentiate this function. This is pretty much using the power rule here because the variables agree, right? I have an x here and I have x, they agree. So variables agree because I'm doing this in terms of x. So that's just going to give me 3 times 2 times x squared minus 1. Basically, this is 6x, right? So this is called the explicit format. This is clearly defined. The variable agree. D of dx of 3x squared. Now I get 6x. Now what happens is, if I want you to find the derivative of the function y cubed dx. So now, as you can see here, I'm finding this derivative in terms of x. But the variable on top is y cubed. So how do you solve this? We use, again, the chain rule format, okay? Let me recall the chain rule. Chain rule. If you guys remember the chain rule. So if you have any function, u to the power of n, and you want to find its derivative, get derivative. It gives you what? N times u to the n minus 1 times u prime. Okay, that's the general form of any, when you want to use the chain rule. We're going to apply that here. Now, again, the variables in terms of x. So basically, the derivative is going to give you 3 times y squared, which is basically 3 minus 1, right? Times dy over dx. We are assuming that this is the derivative, okay? It's going to give you 3y squared times y prime. Basically, this is utilizing, again, the chain rule. And why do we do that? Because the variables do not agree. You have an x here, you have a y cubed here, so you have to use the chain rule to solve this problem. So it's going to be 3 times y, 3 minus 1 times dy over dx, because these two variables do not agree. This is why, and this is how we use an derivative, and to find the implicit, to use the implicit format, okay, to solve for a derivative of a function. This is called differentiation using the implicit format. So now, again, let me recap this. So if you have a function like this, right, where y is clearly defined in terms of x, you just go straight up and just find it as usual. This is going to be 6x. Now, in this case here, y is not in terms of x. So as a matter of fact, let's try and work on this problem. So I hope you wrote this down, guys. So let me do this. So let's assume that we wanted to find the derivative of this function, because this is written in the implicit format. Okay, I'm finding the derivative in terms of x, so in terms of x dx, right? So the derivative here, because the variables agree, is just going to be 2x. Now we have a case where we have a y and we are trying to find the derivative. So I'm going to use the chain rule. It's going to be minus 2y times what? dy over dx. And then plus, again, I have another case, 3 times 3, right? Times y squared dy over dx. I'm using the chain rule. And then the derivative of the constant is 0. So now we have 2x, right? Minus 2y dy over dx plus 9y squared dy over dx equals to 0. Now we are not done. We are solving for dy over dx. We want to find the derivative in terms of x. But y here is not a constant, again, is a variable, and they do not agree. So we are solving for dy over dx. So from here, what can we do? We can put dy over dx as your GCF, your greatest common factor. You're going to pull it out. So dy over dx times negative 2y plus 9y squared plus 2x equals to 0. Okay? And we're going to shift this to the other side. So I'm going to continue here. So that's going to go back here. So we have dy over dx times negative 2y plus 9y squared equals to negative 2x. And now to solve for dy over dx, I'm just going to divide both sides by this expression. So it's going to be dy over dx equals to negative 2x over negative 2y plus 9y squared. And this is how you use the implicit differentiation to find the derivative of a function where y is not clearly defined. Okay? So that's it for today. Thank you.